I will just go over the agenda and also just a brief back into indexing, and then we'll come back to where we were before. So our agenda today is Python lists. I'll skip introductions because we are recording right now, in fact. So if you have, so just as a heads up, this will be posted on YouTube later. So we'll be covering indexing, slicing, list functions, and also a demo at the end. I'm not sure when we arrived, but we'll just go over this really quick. In that you index starting at 0. You can't index out of the array, or otherwise they'll throw a list error. I'll show an example of that. So you index it, you start indexing 0, the first element being 1 in this case. You try to index out, but it'll throw an index error. You can index from the back as well, -1 being this element right here, essentially 1 from the back, or in this case, it is the 1 from the back. And then you can do that for as much as you like as well. And then you can also run into index errors if you try to index out from the back. So if you have any questions for the people who came late, then please come and ask questions. Yeah, so you can do some setting of the actual values itself during this mutability. Yeah, our -1 inverse list. Yeah, that's absolutely correct. The reason why that is because the two optional parameters that you're passing in for the first option is 0 because the default is 0 and it starts at 0. The next optional parameter or default parameter is the end of the list or the length of the list. So essentially, you try to go from the end of the list to the beginning of the list, indexing backwards, or using the -1 step, and therefore it'll go backwards. So more on splicing. Let's do some more slicing. So the question was, why does this example not include 0 or not include 1? You can see that it goes from 5, 4, 3, and 2, and it doesn't do 1. The reason why that is because the end operator, or rather the end parameter, does not include. It's not inclusive. So it is sort of the same idea once you go from 0 to 4. It doesn't include this 5 because the last element is not included. So if you go from 4 to 0, 0 is not included, so therefore 1 won't be printed. So let's see, where's this? Yeah, so this is what I was talking about in regards to the default parameters. The default parameter of this is -1, I believe. So actually, sorry, it's not exactly -1, but it's essentially to the end of the list. So therefore, you start at 0, 1, 2, 3, and then it goes 0, 1, 2, 3, yeah, to 4, and then it goes to the end of the list. The optional parameter of this being the end of the list. Might be, it's not exactly that. It's not exactly the length either. Actually, yeah, the optional parameter in this case would be the end of the list. And then if you try to index out to the end of the list, normally it'll throw an index error. But if you want to include that last element, you go 1 above what you can usually index. In this case, the optional parameter is not the end parameter, but the first parameter, that being the beginning of the list. So you go from 0, 1, 2, and then not including 3. So that would be 0, 1, 2, not including 3, which would be the 4 in this case. So 1, 2, 3. And then in this case, here, I'll make it even better. The optional parameter is the beginning of the list, the end of the list, and -1 is the parameter that you put in for the step. So therefore, it would then reverse the list. So you're going from not quite to the beginning of the list, because if you try to do this and this, it print out, I believe, empty, unless I'm mistaken. It does print out empty, but it's something close to the end of the list. And that way, you're able to reverse it. So as far as what this would print, you have no start parameter, you have no end parameter. So therefore, the optional parameters or the default parameters of those is the beginning of the list to the end of the list. So therefore, this prints out the entire list. This is just an example in which you do the exact same thing, except you have a step of 2. So it'd be 1, 3, and possibly including 5. I think it does include 5. Yeah. And then this is an example of what Camilla had said before about this reversing the list. So good. Right, cool. So we sort of had this list data structure. We've been interacting with it through slicing and initialization, as well as indexing as well. But there are also just a variety of other functions that you can use with a list in order to modify or to sort of work with what is the actual contents of the list. And this is by no means an exhaustive count of all the list functions. In fact, in order to get that, you might want to Google Python 3 list functions over here, the Python docs. You can see that there's quite a lot. But we'll just be covering perhaps the most important ones. So let's see. You begin with this initialized list of 1, 2, 3, 2. This is something that we've seen before. And then what happens when you use the append method with the element that you want to append to it, you place it at the end of the list over here. And not only do you do that, you modify the list itself. So it doesn't return a copy of the list. It is, the mutable data structure itself. So when you do that, you get 1, 2, 3, 2, 4, because 4 has just been appended to that. Let's see. I'm gonna make this not just. I'm not gonna make it pop too, because the most common use case of pop is that it removes the last element. Oops, I should be working this. It removes the last element, the last index, and then returns that element as well. So you have initialized as 1, 2, 3, and 2. You first print A, so that should just be 1, 2, 3, and 2. And then when you pop it, it will return the 2 because it removes the element at the last of the list. And then when you print A again, the list should have been modified such that the last element of the list is no longer there. So you can see that you start with your original data structure, you pop it, it returns 2, and then you print A again, and then no longer has the 2 at the end. And then you can pass in parameters as well, such that you remove things in the middle of the actual data structure as well. Although I would advise you actually to not do this for reasons I won't get into now, but essentially there are certain operations in Python that's for lists specifically that run slower than others because of the way that the lists are implemented actually in the depths of the language. So the difference between pop and remove is that you can see that when we try to pop the index at 2, it returns a 3, and then it modifies it such that you have your 1, 2, 2 list afterwards. And in this case, it actually removes the first 2. Yeah, so it actually removed doesn't remove the actual index, but removes the first case of what you pass in here. And this is an example of a function that may run slower if you have like a longer list, but we don't want to get into that right now. And also when you do that, it doesn't return 2 as well. So you can see that most likely this will print a none. And then this is different from when you popped it. It actually did return a value. And then finally, insert, another example of something that most likely you probably don't want to do too often, or if you have a very long list because it'll run slowly, is insert. Let's see, inserts 10 at index 2, right? So the first parameter is the index that you want to insert at. So in that case, it'd be 0, 1, and then 2 over here. It inserts sort of before. So this, it would be index 2 if you had inserted, once you have inserted it. So you can see that is the case, that you have index 0, index 1, and index 2. And because you inserted at index 2, 10 is now there. Let's see if I can show an example of why you don't want to pop or insert, or you don't want to pop at a specific index, and I'll show you why that may be. So we're going to create a very large list of, say, 1 million elements. Not going to print A, but we're going to just see how long it takes for these functions to run. So let's see. Let's pop. Okay. More zeros to that. So pop will be very quick, but then insert should be very slow if you try to insert in like the middle of the actual. So pop is very quick, and then see how long it takes to get to here. That was all right, so maybe we'll add another 0. Insert 10 at index 2. Oh, wait, yeah, insert 10 at index 2. I think generally these data structures are quite efficient. From a computer science perspective, this operation should take a little bit longer, but we can get this down. There you go. So an example of why you may not want to insert is because generally, if you insert, see, if you do this and just comment out the actual insert, this will be pretty quick, I believe. Yeah, this should be pretty quick, but then this itself should be relatively slow when comparing the two, although still not super slow. If we can use the timer function and get more into that, then I would, but it's a little bit slow. Let's see, Daniel, sorry to interrupt, I only see half your shared screen. I don't see the console. So let me get to this question first. Can you do it with a string instead of a list? Yes, and the reason why that is actually, so I'm not sure by it. You can do indexing and slicing of a string, but because what it does is that it converts a string into a list prior to doing that. Once you try to use any sort of indexing or slicing operations on it, and you can see like an example of that here. I will show you. Okay, this should be fine. So rather than, oh god, I should really be working these. So rather than this being a list, now it's string A, B, C, D, E, F, G. Indexing works, as you might expect. You know, I try to get the character at index 0. It's A. Slicing works, but perhaps not in the way that you may expect. So for example, you want to slice from 0 to 2, you might think that, okay, it's AB, right, 0, 1. But then when you do that, actually, it does work the way that you expect. See if this works as well. Yeah, so slicing works with the list as well. But then because a string is an immutable type, when you try to append something, not only will string not recognize that function because string object has no attribute append, it's a list. List has that function. If you cast to a list first, then you would be able to then see that this is now a valid operation. Just append a to the end of it. Because append is something that modifies the actual mutable data structure of list, and a string is an immutable data structure, you won't be able to append to it. And in fact, when you do things like string addition, a is equal to a plus another string. Let's add a to the end of that. Oh, God. It creates it creates a new string. Actually, it doesn't append to the end of it. The details of which you might learn in computer science class regarding data structures and algorithms. But essentially, rather than just adding a to the end of the string, what it does is that it copies the entire thing, adds an a at it, and then it sends it to a. So it's a much slower operation, which might come into play if you sort of work with long strings or long lists, or long strings as opposed to long lists. So this is sort of a interesting demo of what the capabilities of a list are, sort of combining everything that we had just seen. In addition to what we had learned last week in regards to infinite loops and what happened here? Name is equal to main. I'll just ignore that, I guess. Hopefully the indentation is not okay. Config list if invalid syntax. Line 38, I see. Okay, somebody over here, I guess. I'm a little bit confused about which one I should be using, but get rid of that. So there's a few configs that you can set. First, it runs through this infinite while true loop. It prints out this cursor for you to sort of type into, and then it waits for your input. In this case, if we type exit, it'll just let's go here. Oh yeah, I think it'll run this one again. So actually, I will start this again. And when you exit, it should actually exit the terminal because you just input exit, it reads config is equal to exit, and it breaks out of this input loop. If you do it again, try to set a config like screen witness, which just initializes the list. Oh, right, yeah. So you try to set one of your configs, but it has to be in the format of configs equal to the value, say like 100. And then afterwards, that config is set. So therefore, when you exit, it should actually kind of confused about what this example is because I didn't quite. I wasn't the one who wrote it. All right, yes. Let's print out config list once we actually exit. Screen brightness to 100, and then when you exit out, it should print out, your list of screen brightness. And how that does that is that it takes your input, it splits this parameter or the string that you just put in into two parts: the screen brightness part and the actual integer part. it checks if it's in the config set, that being set over here. And then once you exit out, it'll just print out config list. So yeah, that's like some things that you can do with lists. You can write command line operations, although this is by all means sort of it's like a small part of what lists are used for in an actual computer science or software development context. Yes, Camilo says you can always convert a string to a list. Yes, that's true. The difference being that when you do so, it then becomes a list, which is sort of a mutable data structure, and then in order to get it back into a string, you have to use the join function, which I can actually, I think this is quite a useful list function, so I will sort of demonstrate that as well to go back to that point. So you have your string as was before ABCD, ABC, D. If you print the string cast to a list, as Camilo said, you convert it into the list itself. You can see that it's not the string itself, but rather it's the list of the individual chars of the string. And then once you have that in that format, you can convert it back into a string by using the join function, which you take all the elements inside of this list, and then you put them together with the separator over here. So when you do that, it becomes ABCD again. If you change the separator to a dash, it'll print out A dash B dot C dash D dot E in string format. So as I said before, this is all the things that you can do, or all the functions that work with the list. In fact, that itself was a string function that took a list in as a parameter. So there's even more things that you can do with lists that we can't possibly get through in all the time today. So now we're under the 5 under 5, which is in which you, the audience, answers 5 questions in 5 minutes. And I believe that Emily will be taking over for this.
Yeah. So let's start the 5 under 5. Okay, that's perfect.
Awesome, great.
So let's start with the first question. So as you can see, we have a section of a code on this screen. So can anyone tell me what the output would be for this code? Okay, so here is the answer. So as you can see, the output is actually 4, cat, and 1. So the reason for this is because the first start option is not given, and the second stop option is also not given, which means that it will start at the beginning of the string and it will move all the way until the end of the string. Note the negative in the steps that's moving backwards. So it'll start at 4, which is the first index in a string that is going backwards, and then, yep, perfect. If everyone understands that, then you can see how the output would be 4, cat, and 1. So let's move on to the next slide. Okay, so what is the output of this code? Okay, perfect. So as you can see, yep, the answer is boop. That is correct. And just as a reminder of something you might have learned before, since the first if statement is an and uses an and expression, the statement will only evaluate the first part. So it will evaluate if A is smaller than 10, and if the first condition is false, it won't even check the second part, which is 4 in A, and it'll just skip to the else statement and print boop. And it's similar to an or expression where if the first condition in the expression is already true, the second one won't be checked at all. So it will, like, the program will try and save the time and just skip checking something that doesn't need to be checked. Next question. Question number 3. Now you have this piece of code. What do you think it will output? This one's actually quite tricky, so. you guys are actually correct. It will be an empty list because it starts from the negative indexing and it's trying to go all the way back to the beginning. But since a list can't, yeah, well, you were correct in guessing it was an empty list actually, because of how the indexing works. It won't be able to access the earlier indexes in the code, so it'll just produce an empty set. Okay, fourth question. So here is an example of a piece of code, and you guys will have to try and spot the problem in it. So let's go into the answer slide. And that is correct. As you can see in the second line, it uses two different types of quotation marks. And that doesn't really work in Python, so you should only use one set of quotation marks. Yes, it is. It's super hard to spot these problems. But it's great for debugging that you can actually see where the problems in the code is. So yeah, just remember that each pair of quotation marks should be only used to either use the double or just the single when you're trying to identify something as a string. Okay, everyone, last question. It's another kind of error that could happen when writing your code. See what the answer is. It's all good. It's all good. So as you can see, the problem with using true equals false is in the first line because we aren't able to use keywords as variables or identifiers. So since at the beginning in the first line, they're trying to use true as a variable, but in the loop, they're trying to use true for it as like a Boolean, and that is impossible. So it's just you try and avoid using keywords such as true, false, and or not, these kind of terms as variables because they're actually used as identifiers in programming already. So just avoid using these words as variables. Okay, cool. I think that is the end of the 5 under 5.
All right, great. Thank you very much, Emily. Even though I couldn't hear you the entire time, it seems like we've got some great participation. So I guess I'm going to skip the workshop because this is very similar to that example that we had before regarding system preferences and configs. So because we're coming up on time, I know that people will have to leave soon, but if you're able to sort of attempt this challenge problem, then this would be very good for your understanding of lists and how to use them. In fact, in this problem, you may have to even look up some documentation about how to do certain things using a Python list in Python or using separate data structures to make it faster. So the challenge problems is in itself. Find the first missing positive number in the list. So for example, 0 itself is not a missing positive number. So let's check out 1. 1 is not missing because it's in the list. 2 is not listing because it's in the list. And 3 is not missing because it's in the list. So therefore, the first missing positive number is 4. If you do the same thing with this next list, 1 is in the list, 2 is in the list, but the first missing positive number is 3, regardless of whatever this is. So the first challenge is to do so without, you can do it in sort of a slow way. Without using any extra data structures, because this was originally a sets and lists lesson, so we sort of have some remnants of that. The next challenge is to do it with using a set. You may have to do some Googling on how to exactly use that, but the applications here is pretty straightforward. And then finally, the challenge is to do it both in a way that scales very well. It scales such that when you run this algorithm, it goes pretty fast regardless of how long the list itself is. And also you have to do it without using any extra space or any new data structures or converting your existing data structure into something else. I'll go over the answer, and this function, or this function itself, essentially what it does is that it just times how long a function takes. So we have three solutions here. One with the new data structure that you haven't learned yet. This uses a set, and it uses extra space as well. So this is sort of fast, but a little bit cheaty way, because, or actually it's not like a cheat, but it just doesn't fulfill the actual stipulations of the challenge itself. This one does, but it is quite slow, and we can see exactly how slow later. And this one is the version that uses no extra data structures or extra space. And it uses everything that we learned in this lesson, in addition to the previous lessons regarding for loops. And also it runs in a relatively quick way. So I'll just give sort of a quick go over if people are still on this call. Let's see. So regarding extra space, it uses something called a set. What we do is that we take everything that in the array, and then we cast it or convert it into a set. And what a set allows you to do is that it allows you to look up whether or not something is in the set or is not in the set in a very fast time. It's not sort of a search through the entire array. It is just we call it a constant time operation or one operation. So then you go from 1, starting at 1, the first positive number, to the last possible positive number, which would be the length of the array. Because if you consider that you have all these elements in this array, and if you have and all of them are there, then the last possible one is the last element, or the actual length of the array. So if you run this function, it checks if it's if when you're going through from all the possible positive numbers, checks if it's in the set itself, and then if it's not there, you return that number. Otherwise, you return one above it, which is all the possible elements that could be there are in the original array, and then therefore you want to return 1 over that, which is the first possible missing positive element. This one is slower, and it looks very, very similar, but essentially what you do is that you don't ever create this new set. You don't use extra space, and you don't use the data structure of this set at all. But rather what you do is that you check if n is not in the array. In fact, this keyword is exactly the same. But because the array is an ordered data structure, you can't do a search very quickly for the actual, what is inside of the array or this little list. So therefore, it'll run very, very slowly when it starts to get to larger elements. And then I can show you, and then this I can get into later, but just show you that it took 12 seconds for a list of 10,000 elements for the slow first missing to run, which was what I had said regarding slow. And then for the one that didn't fulfill the challenge stipulations, it took just 0.25 milliseconds, which is 2 orders of magnitude, probably 3 orders of magnitude faster than the slow function. But you can see that my implementation, which fulfills the challenge because it doesn't use any sets or any extra space, it still runs in a reasonably quick amount of time, even though it's 10,000. It's a matter of 2 orders of magnitude. It's not that much slower than using extra space. So we'll see how we did that. So the idea is, and this would make more sense if you sort of knew what sets were. Again, this lesson used to be about both lists and sets, but essentially what you do is that you sort of use your existing array as a way to check whether or not that element is already existent in the original array. You use it sort of as a set itself. So you use the index of the array as a way to check if the number is already in the original array. For example, if you're trying to find like the first positive missing number, and you want to check if 1, 2, and 3 are in the array, we then can use index 1 and index 3. And we can set it as negative to indicate that yes, it is there. So therefore, we sort of change the search operation from scanning the entire array to just an O of 1 index access. And in reality, because we're trying to sort of conserve space here, we use index 0 and 2 because it's indexed at 0. And the idea is that for every single one of the numbers that are not going to be in that set of numbers that will be sort of impossible answers for the first missing positive, you set that to a number that that won't interfere with what we're going to be doing next. And what we're going to be doing next is specifically that if that number is in the set of possible missing numbers, you set it to a negative. And what this does essentially is that if you had already set that before, if you have copies of the same element in this first set of possible first missing positive numbers in the actual array itself, then it won't set it to a negative again, thus making it positive. It'll just keep making it negative. So therefore, when you actually iterate through the actual array itself, the first missing positive is actually the first positive number that is positive in the array, because we had set everything from prior to that already as negative to indicate that it is in the array. So we return the actual index itself. So that is how you do the challenge problem.